Assalamualaikum and hi everyone. So today we meet again in this video and I'm going to show you one example how to solve the Brayton power cycle. So let's have a look at the questions that we have over here. And let's pause this video for 1 minute so that you can go through the questions, and if you are going to solve for this example, let's copy this question into your notebook. Alright, I hope you have read carefully the questions over here, and please remember that this is the chapter from your Brayton cycle. So what we have down here is the TS diagram and also PV diagram. So we are going to solve this example using the TS diagram. So let us go through very quickly on this question over here. So we are given on the compressor's inlet, and it is this problem is about single stage gas turbine with the inlet to the compressor is 27 degrees C, and that we are also given maximum temperature which is set at 1300 degrees C, and we are going to see which state is this 1300 degrees C is. And then we are given pressure ratio which is 8 to 1, and also not to forget that we have compressor and turbine isentropic efficiency 82 and 85 respectively. And you are asked to sketch the cycle in TS diagram, and also you are asked to find turbine's actual exit temperature, which is your T4, but we are going to have a look at your TS diagram later. And then next we are going to find for your network output of the cycle, which is you need to write down first the equations for your work net, which is with work of your turbine minus with your work of compressor, or also work out minus work in. So this is the equations that we are going to use. You will see later on your TS diagram sequence starts with inlet to your compressor as state 1. Next, you are going to find the thermal cycle efficiency. So you have these equations down here. And finally, you are asked to find a new cycle thermal efficiency if the compressor is working at 100% efficiency, meaning that the compressor works isentropically lah, right? So while the turbine remains work at 85%, so you need to also briefly explain your findings for questions D. So down here is the equations on how you are going to find for your new work net. So basically it's the same with your B, but now we are finding the new one because your new Q in, which is at your you only considering T2S, not T2A. Alright, so before we look for all the temperatures values, so let's have a look at your TS diagram over here. Right, so I'm going to show you how are you going to sketch for your TS diagram. But before we move to solving the part, so let's have a look at I'm going to show you here how we are going to sketch for your TS diagram. So first we have the TS plot, and then you make use of two lines for your pressure, high pressure and low pressure, and label all the arrows. And we are going to start with state 1 at the bottom, 2, 3 and 4. And also next we are going to plot the isentropic efficiency of your compressor, where we have this dotted line over here that mark as your isentropic efficiency at your compressor. So T2A is actually the actual temperature at T2. And next we are going to have isentropic efficiency at your turbine. So we are going to have the 4 and also 4A. Alright, so you can see because of your compressor over here and also your turbine right over here having an isentropic efficiencies 82 and 85% respectively. That is why you are going to have this dotted line for actual value at compressor outlet and temperature value at isentropic outlet. And the whole thermocycle process starts with state 1 at the compressor inlet, and you are going to have a clockwise sequence 2, 3 and 4. So given to you the highest temperature in this cycle is 1300 degrees C, where the complete combustions happen, right? So remember this line over here 2 to 3 is the process where combustions happen, and this is where the fully developed combustion process ends before before the gas comes into your turbine over here. So that's why you place your 1300 degrees C at state 3, and your inlet to your compressor temperature is 27 degrees C. So what you need to do is that you need to list down, right? As you can see over here, you need to list down all the given value. So you have the pressure ratio, which is the high pressure over low pressure. So P2 over P1, P3 over P4, and the ratio is 8 to 1. So you got the pressure ratio here is 8, and then you list down your temperature 1, temperature 3, and the thermal efficiency of your compressor. Remember, isentropic work over actual work, whereas your isentropic efficiency for your turbine is actual divided by isentropic work. Right? In the next video, I'm going to show you on how to solve state by state. Please stay tuned.